start stream. Was the last problem new or was this problem new? The fruit basket one was new to the Jupyter notebook, but I've solved it before, so it wasn't that hard to figure out. I still didn't do a time or complexity analysis, by the way. I'm sorry. His video always starts me doing complexity analysis. Complexity, and then we'll do time complexity. What else? What else? What problem is this? Oh yeah. Okay. So, and these are all and these are in this one of the reasons why. Whoa. This is one of the reasons why a sliding window is a great pattern, right? Because it's the for loop looking at each, I'll say, fruit tree into the list, right? That's why now space complexity, same thing. We can store at most k or k plus 1. There's no k, so really it's going to be, it's O1. And it's O1 space complexity because we store at most 2 types of fruit in the frequency vector. Cool. That's that on that. And that lines up, right? Space O1 time ON. Next problem, it's a hard one. Ooh. I'm excited for a hard one. That's a pause. Mark down. Doing a hard one today, wow. Kind of crazy. Our format is, okay, top level. Yes, okay. Problem statement. Given a string, find the length of the longest substring, which has all distinct characters. Okay. So if I understand this problem correctly, we're attempting, when given a string, to I should be commenting these problems, right? Because generally if I don't have an explanation, then before I even move on, I'm gonna explain this one, because if I don't do it, I'm literally gonna forget. Okay, so what's our explanation? So we're gonna, using a start pointer, a frequency, dict, and tracking our I guess really it's max fruits, will iterate over the list of fruit trees. My phone's updating the side, that distracted me. We'll iterate, that should be over the list of fruit trees, and we're gonna add it to our frequency dictionary, and what is this? increment once present. Cool. Our window, I call this window, I can call it window shrinking, but it also could be expanding. I'll call it window adjustment. Our window adjustment condition is when we have more than 2 fruits in the basket. And I'll say in the frequency dict basket. We'll subtract 1 fruit from our start fruit and delete if it reaches 0. Increment our start pointer, then update our max num update our max num fruit with current, I'll say with the max of the current num fruit, or end minus start plus 1. That's it. That's our explanation. I can read that back, and these couple of sentences should explain everything about the code I just wrote down here. Yes, comments in the code help. And this is actually a very clean function. It's 22 lines of code. I could remove some of these. 4 or 5 new lines. 17. A big deal. Anyway, what am I whispering? Next problem. Complexity solution. Yep. Okay, next problem. Longest substring. I almost said hardest substring. Longest substring with distinct characters. So I'm assuming this means the longest substring with all unique characters. So for example, we have on the left here an example. We have some string. We have A, B, C, C, B, B. So if I just look at this problem, right? I just look at the string. What's the longest substring with distinct characters? I think A, B, C. That's 3. Right? Okay, cool. Next one, A, B, 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 A, B. That's 2. Okay. Yeah. And A, B, C, and C, D, E. Okay, 3. So essentially, we have to look at this list, and it's sliding window. So we're gonna be looking at multiple, chunks of the array, multiple substrings. Using a start pointer, we're gonna look at, with the first example in mind. So with the first one. So with the first example in mind, we're gonna look at A. And we're gonna say, cool, add A. Okay. Yeah, so A is a part of our substring, part of our window. Our start and our end point to A. We're gonna see another A. Ooh. At this point, we know that this substring is no longer valid, right? Or at least how do I say this? We've hit a point where our next character is equal to our last character. That's true. That's completely true. Okay, so what would we do in this case? Well, this is a potential substring, right? Just A on itself is a potential substring. So when do we know to move our start pointer? I'm looking basically for 2 things, right? When we do sliding window, we're looking for, okay, how are we gonna increase our window? And then what are the conditions for decreasing our window, shrinking, or adjusting our window at all? Well, the conditions in this case are if we are going to add a character to the substring that is already present in the previous substring, right? And I'm not sure I want to track substrings, but definitely want to keep track of the characters that are already in the substring. And I haven't used a tracking array yet, but that could be useful here. So we can keep track of this. We can keep a scene array, which I think I probably used before. So we have A already in the list. If A is already in our scene and we're going to add A again, then we probably should move our start. I'm going to just say that. Okay. Now the algorithm really should be continue to add things to scene as long as they're present. But the only reason why we moved our start is because we already have an A not only present in the scene list, but also it's pointing to another A. We added an A. We basically added an A and removed an A. Removed as in we moved our start pointer, which is not, I mean, sure, that English I think works, right? Cool. So now we add our B. B is not in scene, so it's safe to add that and continue to. I might even do the calculation each time we do it, to be honest. So our max, the length of a longest substring is updated every time we iterate, I guess. But that's kind of repetitive. Adjusting our window is literally just for these conditions. So there'd be an if statement saying if, new character in scene plus equals 1 on start, and update our max. Now, do we really only want to update the max if we see the same character twice? No. So at the end of that, outside of the if statement, our window adjustment condition, we're going to have a max gets max of our current max, and then our end minus start plus 1 formula, which is our offset, how we look at the window. So for example, our end, in the case where we had to add that A, our end was pointing to the second A, which is index 1, which is index 1. So our start was pointing to 0 in the next one. So it's 1 minus 0 plus 1. Now the reason why, our start is now pointing to the same one. Okay, yeah. So this max check is after our adjustment condition. Our adjustment condition is that if the new character, if our second A, the character that our end variable our end tracking variable is pointing to, if that character is already in the scene list, which it was at this time, or is to be, which it was at this time, we're going to increment our start. So our start really is, it's going to be 1 minus 1 plus 1, which basically is 1. So our new max is 1. Cool. We add our B. B is not in scene. We never touched it. We now have a max length of 2. Great, we update it every time, that's fine. We look at, what is it, D? No, C, my handwriting's terrible. Yeah, so we add our C. C is not in the list. We have now 3, okay? Technically speaking, so we have an if statement for our adjustment window. We've normally had while loops because sometimes conditions can stay the same. So I say while the new character is in scene, really it's, there's another condition though, isn't there? And what I mean by, there's another, we have 3. Okay, let's stick with that. So we have C. We have the substring ABC 3. We have another C, right? So C's already in there. We're gonna move our start up to B. Okay. Okay, so we have no management for our scene code. We have no management for scene. A little tough there, right? We have no management for scene. And by that, I mean we have no way to adjust. Like, let's say, for example, we removed all the B's. We'd have to go in and remove B from the scene list because it's no longer a part of our window. We have to, the scene is technically saying that these are all of the distinct characters in our window, which is already really tracked by our window. So there's some overlap there with how we're tracking this, right? But, the way we track it is influenced by our adjustment condition. So let's take a look at that again, right? I'm running into a bit of an issue here. I think our max update is fine. What I'm worried more about is our adjustment condition. So we've been adjusting previously when we say we already have this character, right? That's a valid adjustment condition. I think that's fine. When we've seen the character, we want to move our start. It's easier to add and remove from a dictionary than it is a list, right? In terms of, think about the longest input you could have, that array can get pretty long, okay? That array could be n length if we're not careful, right? So that's a little bit tricky, right? If we tried it with a dictionary instead of an array, let's see what a dictionary can do. So dictionary we could track the character in the index. That's fine. So we've seen we have A at 1, we have B at 2, C at 3, index 3, right? So we see another 3. Well, we have another C. So what exactly does that mean? Well, yeah, I'm just trying to understand how to adjust our window and what the right adjustment is. Should we reset the window when we have a repeat offender, a repeat character? So without worrying about the code itself, if I were to do that, I would have to remove A, remove B, and remove the other C, right? Or at least remove that C and then update it elsewhere. So, I mean, yeah, that's pretty much our adjustment, right? While our start pointer, so what I'll really say is, because there's kind of two conditions here. Hold on. There's two conditions, right? There's one for adding a character to the scene dictionary, and there's also one for then updating our window. So we're gonna say basically if new not in scene, we'll say scene at new character gets our index, right? Otherwise, oh, yeah, this code always runs. Okay, so our window is automatically adjusted, and this is the first condition, right? Our window is automatically adjusted by basically saying scene at new gets our end index. So for this example, we start back from the beginning. We add A, which is index 0, to our scene dictionary. Okay? A index 0. We update our max, our length, scene start, whatever. will be 1, I think. I didn't finish the other codes. I gotta make sure I figure that out. Okay, we have our second A. We automatically update our A was last seen at index 1. Okay. Now, what are the reasons for updating our start? The fact that A was already there, or God, what are the conditions for moving the window around? Basically, we have to throw away the entire previous window. Does that make sense? We essentially have to toss away the entire previous window. So, for example, when we add our A, it's a small example, but our start needs to move, right? We're always going to increment our start if our new character is already in scene. Now, what happens when we have this massive substring? Not even massive. What if we have a character greater than or anything more than one move and we have to adjust it more than once? So a while loop running once, an if statement running once is not better than a while loop running once with the possibility of running more than once. So what I'm saying here is that we need to have a while condition or a way to iteratively move our start such that we appropriately adjust the window. So the condition I think is just while But do we want to do that after the fact? That's a whole other thing. The max update. Understanding when to do the tough, right? Have I solved this problem before? No. But I think I might have actually. Hold on. I did solve it already using a scene array. Oh, and I just adjusted the count, but I'm not using a sliding window though. But what's the complexity of the solution I have? Maximize scene. Append it. We've seen this before, then rewrite scene to be our new window. Yeah, this is an end length. This is an O event solution with with potentially n what's it called? Space complexity. So if we want to reduce the space complexity, this is a good way to do that. But it's a good solution too. I like this one. I like it a lot. But back to n length time n time complexity O of 1 space complexity. Well, I guess really O of. I guess worst case, no, O of n. We just need some way to track what's already in the. We need a way to move the window appropriately and under the right conditions. So I don't know, man. I don't know. I'm just trying to think for a minute. We want to continually expand our window, right? So what are the conditions? Our start and our end point to our entire window. The management of that window is important, and what we do with that substring is important. What's the condition for adjusting our window? In layman's terms, if we have already seen, if the character that we're adding to our window is already present in the window, then we want to adjust the window. We first probably want to calculate our max. If we're going to add it first, don't add it until, right? Or update the window to point to the one you're on. The point is, we don't want to erase the previous window, and we don't want to be calculating, right? But the point is that if you adjust the start first, the calculation is fine. So the point is, we want to move our start let me get rid of this scene. I think it distracts me. My first line was to add a scene, to add that character to the scene, but I'm gonna remove that. Our condition is to bump up the start. Oh, is it really just one bump? I think it is just one bump. Yeah, I think it's just one bump. I don't really think it's a while anything. I think it's literally a one bump thing. Well, let's run through it, right? So our end is our looping mechanism is going to track our end, our at the end of our window, the end of our window. The start is the start. If no, and why is that a no? Before I even wrote the code, why is that already a no? Well, let's say for example we have unique characters up until let's say for example this is not an A. Let's say this is an F. We want to keep A, F, B, and C, right? Once we hit the C, C's already in our window, correct? We've seen that character before. And so we'd want to bump up the start and using it's still a 4-character window, right? But in this case, this is not a valid substring, right? Because if I have A, F, B, C, I'm going to add another C. Our window should really start with the new C. And we shouldn't calculate that, but we should still get that 4, but we can't just bump the window one time. Our start now needs to be the end. Does that make sense? So let's say I'm using some external tracking, right? Let's say I have no way to keep track of stuff linearly. In this case, right, if our new character is in our scene tracker, our start now needs to get our end. But before we do that, calculate our max. We could bump the start up one time. Yeah, that's it. Okay. So do our max update. Okay, here we go. This is our adjustment condition. I believe that's right. Max gets max of max, and then if we do our start plus equals 1, it'll be end minus start plus 1. And then we're gonna take our start and give it to our end. Okay, why does that work? Well, let's rewrite this real quick with our old example. A, B, C, C, B. What, B? What is it? B, B. Okay. Our start points to index 0, character A. Our start points to index 0, character A. A is not in our scene. I'm still back down to this same solution. The reason why I don't like this solution is because we have potentially n time or space complexity. Now, for the really, really large list, you don't want to be storing this kind of information, you know, repeatedly. That's my issue, right? It's only going to be as long as our distinct character. The scene array. I haven't even updated scene either. My Bible app is open. Hold on. I might just look at the solution. And this is a hard problem. Wow. I got distracted for a minute. That's bad. So these problems usually build on each other. So the last problem was this fruit basket problem, where we had to keep track of how many fruits we had, and the space complexity was, one, it's constantly only two. This space complexity is slightly worse, and I think that's okay. I think trying to make the space complexity smaller is what's kind of keeping me up here. But basically, if we've already seen this, we want to bump up the start to adjust for the extra character we just added, so our window is not one bigger than it should be. So we're gonna increment the start. We have to do that. Then check our max. That's an if statement. At the end of the if statement, we haven't done any scene tracking management here. We're gonna set our start to be our end. Okay, our current new character is the beginning of a new chapter. It's a new window. We don't have to move it 10 times. We can just move it over once. Okay. Let's talk about scene management, and I think we can run this solution through. So what happens with scene? I think scene gets a new, yeah. When it comes down to it, we pretty much have this exact same solution. It's O of n runtime. It's at biggest space complexity, and this one I have here is literally it. I think that's literally what it is. I do want to look at the one. It passes these test cases, right? And I can't come up with one harder than that. So I'll have to cut it up eventually, but let me just start here. So I had a max length calculation at 0. I had scene was an array, which isn't bad. So I could say now what I said was basically our current character, right, is from S at N. Our current character is just char. So I'd say like if char not in scene, I would just say scene dot append the character to the list. Else, we've seen it before, therefore we don't use any sort of window tracking, right? We basically just say, okay, cool, our max length needs an update, so max between the length of scene is great with our previous max length. Yeah. And then we had a count. I don't know why I had cur count. Wasn't doing anything. Then scene gets a new window with our character. and we just return max length. Strange how that just kind of works. Some test cases, as usual. PyTest, PyTest.mark.parameterize. We're gonna pass in a string and the expected output. Our tests here. We're gonna define I'll just put this. I'll just add a test. Takes an S, which is a string, and our expected, which is an integer. I was trying to make it O of 1 space complexity, not to have to keep track of it, but you kind of have to. And the last one you have to keep track of it too, but it was constant time because of that. This is worst case n. You don't have to keep track of everything. If the substring is unique entirely. I'll just assert that our problem, non-repeat substring, given s, equals expected. Okay. We define our tests. We give it a list of tuples. I'm gonna give it the traditional cases as well as my own. I think the substrings first with. You should see at least 3. That one. This one will be 2. Talking about the expected here. And this will be what? 3. Okay. But another one where technically all A's should just be a 1. All unique characters should be something as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This should all pass. Create another code block. PyTest.run. Ooh. Okay, wow. Okay, so the problem with this solution is that if we never see another character again, we don't update our max length. Max length updates don't need to be part of the if statement unless we're adjusting our start, which we're not. So this can be put here, I believe. If that makes sense. So the reason why that works is because, I don't know why I'm getting up right now, but I forgot I was recording for a second. I think it might be too many checks, but I'm not really worried about that. Okay, what solution do they give? How are they tracking windows? I've looked at this before and I was like, what the fuck is this? So they use a mapping, a dictionary to track. They add it. If we already have it, update it. And otherwise, insert. They're tracking. What are they tracking here? But they're still tracking it with a dictionary, so there's not really a way to not. Yeah, I'm just finding different ways to update the max length. I'm just tracking it in an array. I'm overriding array memory. That's not a big deal. They never update the index map, and by that I mean they never. What's it called? They just track the index. Yeah. O of n and k. So let's see. The algorithm space complexity will be O of k, where k is a number of distinct characters in the input string. This also means k less than or equal to n, because the worst case, the whole string might not have any duplicate characters, so the entire end of the hash map. Having said that, since we can expect a fixed set of characters in the input string, oh. Okay, that's funny. No, that's true. It's not O of n. It is, but n is also 26, because there can only be 26 non-repeating. I didn't even think about that. That's kind of funny. Yeah, my solution it doesn't use a win. Well, it's not really using a start and an end. Even here, they don't have a start, right? How do I say this? So the shrinking. So they're using a tracking, but the tracking usually is pointing to something, right? So when they do this window start, they say, okay, max between window start, which is greater, the start or the character at the end, right? Plus 1. Then they say our mapping. Oh, they do track start. Haha. Right? So this is okay. So they have to be somewhere. That looked weird, but so they're gonna extend the range. They're only gonna adjust the start. Right. So with, like, for example, of A, at all B's, you'd say right character gets, this is A and map, nope. Add A to the map with the window end as a key, or as a value for the key. Update your max. So your max length is still 0. Window end is what? Window end is 0 minus the start 0 plus 1 is 1. Max length is 1. You now have a B. B is, so right character is B. B is not in it. Your window start gets, B is not in it. So we don't even run that code. So B gets 1, and our length is now what? It was 1 before. Window end is not pointing to 1. 1 minus 0 plus 1 is 2. Great. We have another B. B's in there. So our window start now gets updated, right, to be the max between window start, which is 0, or the index of our new, no. Wait, what if it doesn't exist? Oh, it does exist. Okay. So increment the index and say our start now points to, cool. But we have the same space and time complexity. Yes, my solution is just more Pythonic. And, well, I wouldn't say Pythonic, but it's what is it? I don't want to dumb down my solution, right? I don't want to dumb it down and say, oh, it's not the window slide technique, but they're also tracking it in a dictionary, right? I'm appending to the end of a list. That's a constant operation. I'm completely wiping the list with a new character, which gives us an entirely new window. Is that memory efficient? I don't know. The max length calculation is the exact same, right? I don't even have to enumerate this. I just use S. It should still run perfectly fine. You know what I mean? So I think there are more than one solution to any problem, as long as you understand what the objective was and how to achieve it. And this solution looks a little cleaner, right? If I were to remove temporarily all of these comments, and to get rid of all this and all this, move these comments out of the way. How much code do we really have here? Let's take a look. again, even this solution, very small solution. And I use an if else, yeah, it's not, it's not that crazy. It's not that crazy. So I'm not too worried about it at all. I said code. This is really marked down. Complexity. Time complexity. This is big O N. As we pass over every character in the array. So this is going to be constant because the most amount of characters we could store are 26, since that is the longest substring with distinct. That's the longest substring with distinct characters, therefore that's the longest we could ever store. Simple as that. Do I like this solution more? For the fact that it looks more sliding window, but they have, again, I have the same runtime, I have the same space complexity, so I'm not gonna nitpick at that too much. Cool. It's only 10 o'clock. I can do another one. Not a big deal. Okay. So now we're combining this idea of substrings and this K character. I don't think I ever solved this problem. Maybe I did. I'm gonna reset it though. Can't undo a reset. Fuck. That's fine though. Anyway. I keep saying code, but new problem. What's our problem here? Given a string with lowercase letters only, if you are allowed to replace no more than K letters with any letter, find the length of the longest substring having the same letters after replacement. My solution explanation? Yes, it is. Did I get one here? I did not. I always forget to do this, but I'll put this in there. I'm gonna come back to this one. Explanation. Okay. So basically what do we do here? Using a scene array and max length pointer, we iterate over the string and add it to the scene array if it's not present already, or we reset our scene array with just a new character. With just a new character, can we update our max length with length with the max okay. That's our solution explained in English. Love to have that. I don't have a solution for this yet. This is the longest substring with the same letters after replacement. One that I conceptually still don't really understand, so it's good to go over this again. I do hope to get through to the new ones tomorrow. I have a plan to get through 3 sections of this by Friday, which yesterday seemed entirely possible. It's Sunday. I haven't even gotten through the sliding window, so we're gonna see how accurate that is. I have, not including this one, which I'm gonna solve right now, I have 5 more problems to solve. So let's think about that for a second. Gotta hydrate, get some water, and get chapstick. Okay. Run it back, run it back, run it back, run it back, run it back. Run it back, run it back. Am I still recording? I am. Wow, I'm so good at this. All right, so. So we're given a string with lowercase letters only. If we are allowed, and laundry's done actually. Before I even start that, let me switch my laundry out because that's gonna be a bitch to maintain. Am I spitting out dryer shit or no? I am not. I am. My dryer thing's full. Interesting. Okay. Let us continue. Ugh. Nothing new to check up on. Got emails, job alerts, which I thought I turned those off already. Anyway. Now I can actually focus. Cool. Longest substring with same letters after replacement. So, without worrying too much about the code, let's try and figure out this problem already, right? A, B, C, 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 B, B. But we have now another variable, K. So actually we can replace at most K letters to make an even longer substring, but it has the same letters. So this is very interesting, right? So just looking at this in general, what is the longest substring with K replacements? After K replacements. So we have A. If we replaced B and C, we'd have A. We have 4. If we had B, C, okay, if we had B, C, C, B, B, replaced the two C's with a B, could do 2 replacements, we have 5 as our answer to this question, okay? Let's start with another one. A, B, B, C, B. K equal to 1. We'd have 4 because B, B, C, B, we could replace the C with the B. If we had K equals 2, we'd have, 5 because we'd have the A and the C get replaced. So it'd be all B's. You get the idea. Cool. If we had 1, I'd probably replace, the C. Cool. So, okay. These examples are making sense. Okay. Now let's talk about a potential solution, right? We have to look at each character and determine, our window here. So I mean, and these problems build on each other. So I expect to be tracking something in this problem, which kind of just makes sense. When we're talking about building a substring, you're normally going to be tracking something, especially when it comes to like non-integer. My phone's being weird. Especially when it comes to non-integer stuff. Cool. So, I wasn't using a start before, so I'm not going to use one again, because I think that's fine to not use one. If I end up needing one, I'll bring it in. We can use another scene array. What's interesting here is that we kind of have to keep track of count, so a dictionary might be better. So as we look at each character, we're gonna hit the A, put in a 1. If not already in the scene, hit A. We're gonna hit A, put in a 1. We hit another A, and put it in at 2. Right? We haven't hit any conditions to adjust our window at all. We have a B, right? At 1. We have a C, 1. We've had a condition. Okay, what's the condition? Well, we now have more than K distinct characters. Or let me repeat that in terms of this problem. We now have more than K potentially replaceable characters. Is that making sense? So what I mean is, let's say for some reason we have some kind of tracker, some kind of pointer at our start being A. We know that we can only add K new characters or K non-A characters to the substring and still be within bounds. So if we have a pointer at A as our start or our current character, we can only add a B and then a C and say, okay, cool, we have, right? And usually this is a greater than, but maybe it might be something simpler than that, I don't know. right? So we have to replace, once we have two other ones, replace it. Basically, we have to keep track of that kind of counting without including our A, okay? So we have to sum the values in our dictionary that are not equal to the A. But anyway, that's a different problem in itself. So we hit a point where we say, okay, cool. We've hit this point now where we have a potentially good substring. We're going to keep a max length pointer that will update later. So max length will start at 0. We're going to, the condition is that, the conditions are that we have given our start A, we have two non-start characters, okay? And K, literally we have, it's the if statement that gets us into the branching, is if the length of our scene or frequency counter, frequency dictionary tracker is, I'm saying now here, I'm saying really greater than K, right? If we're keeping it simple, greater than K. We have more than K characters to replace. Or we have more than K distinct characters and we can only replace 2 of them. So what are we gonna do? We have to perform the replacement. I mean, not literally, but we basically say, okay, we take our start and its count, and we could just say, okay, well, our max update, right? Our max update is going to be our max, between our max, right? And what else? It's going to be the count of our start. So we're going to look at scene, given our start, right? Or we're going to add it's really going to be scene start plus K. Is that clicking? Right? So let's say we're adding a bunch of characters. Now we have A, B, C. Great. Frequency length, scene length greater than K. Our max gets updated to be, okay, our max is currently 0. We want to update it. Our scene at the start, which we're pointing to A, is 2, plus at most 2 replacements, K replacements. So we're comparing 0 to 4, which is our current length of the window. It's 4, right? So how do we then adjust the window? Because we've now stored our max in here already. Sweet. Well, our start can get bumped to what? It can get bumped K places. That doesn't make any, and that might not be true later, but iteratively fix the problem, right? So in this case, yes, it makes sense to bump our start 2 places, right? To get rid of those 2 previous characters. Just to backtrack a little bit, as I'm iterating over this string, looking at each character, A, B, C, C, B, B. Yeah, no, that's okay. Let's go with that. Let's go with that. So we're gonna say, okay, cool. We've gotten our max. We're going to then take our start. I'll just say start. We're gonna plus equals K. All right, we're gonna add K to our start to move it up. Now it's gonna point to B, and we're gonna delete all previous examples or previous counts of our, we're gonna first delete it and then move our start. So from our scene, delete scene, and we'll say like, we can track the character itself. We can just say like, our start char equal to what? S at start. So our start char can be deleted. Then our start can get plus equals K. That's an if statement, not a while loop. We're basically just wiping away the old stuff, okay? Now our start points to index what? 0, 1, 2. It's our start now. It's our start, okay? Our end, and that last iteration, right? Our end, I'll get to it later, but I have where I did the update, I'm kind of like, Anyway, this is where I always get stuck. But we got it this time. So our start is pointing to B. Our end is currently at the second C. A got deleted. Our start points to B. We now have 2 C's. Frequency is not greater than K. We keep adding B, we keep adding B. So we eventually have 3 B's, 2 C's, our start pointing to the B character, okay? We never update this. Our code never touches any kind of we don't update our max length at all, so we're gonna return 4, which is actually wrong. So we want, at this point, I guess every iteration could trigger that kind of work, but also maybe not. We really only want to move our start. We definitely want to do the update work if we've gone further than K. If we have more than K distinct characters, we definitely want to do the update work. There needs to be some work done anyway, right? So this might be a little bit of an else, where we essentially say if it's not in scene, we're still going to do an update with our max, which in that case makes me think we could just do the max update outside of it. Now we can't, because we're using our start, right? We're using our start variable to grab the start's count. So we could keep track of the start count somewhere else and then remove the dependency on the max. So I guess I could bump this out somewhere and then just, I guess update it every time. That's kind of, I don't know. Not sure I like that very much. I want to remove, so let's just repeat it, right? Let's just take the start char, getting our S at start, the actual character, right? We'll do our max update with max at, we'll get the count seen at start char plus K. So when we add our C's and our B's, we're not greater than K, but we still want to say, we're still going to say, okay, cool, go and grab the count of B and add it. So for example, we'd say, we ended our last update, we were pointing to the first C, now pointing to the second C, right? And we're saying, cool, scene, length of scene is not greater than K, therefore we're going to come to the second else. Our start is still pointing to B. We're going to take our max, update it with the count of B, which at this point is still 1 plus K is 3. Okay, that won't replace our last effort. We need to see at least 2 more B's to replace, which we apparently have. We hit our end at B. The second B in the list, second B in this substring actually, we'll say, okay, our start is still B, and our count of B is now 2. So 2 plus K is 4. That's the same thing as last one. We had our third B, starting character still B. We pull out the start. So I have incrementing code above. I don't have it on the whiteboard, but assuming that's all managed properly, we'll add it later for clarity. But now say that's 4. And we just return the max length. So we bump out of this for loop. Okay, let's try another example. See where we can break the code, right? Now, can I outsource the scene track? Yeah, I probably can outsource that somewhere else and bump that update later, but yeah. So let's try A, B, B, C, B, and with a K of 1, okay? So our start's gonna point to, I guess, index 0, character 1. That's A with 1. Our last scene, not greater than 1. So we're gonna update our max to be 1. Cool. We have a B at 1. That's greater than K. We're gonna update our max to be 2. So it'll be the count of the start, which is 1. The start is A, the count of A is 1. 1 plus K, which is 1, will be 2. We're gonna delete A from our dictionary here. We're gonna set our start plus 1. That's gonna point to B, okay? Sweet. We had a B, that's 2. Update our max, that's 3. Oh, okay. Bug, right? Bug. We don't actually, that's not 3 at all. No, it's not. Because the count of B is 2. Yeah, so I mean we can't unless there are, So really, what it comes down to is that there has to be at least K replaceable characters in this current solution. We wouldn't say the length of K length of scene greater than K. We'd say something like the length of non-start or not whatever character our start points to. If we have K other characters in our scene tracking mechanism dictionary, then we want to worry about some kind of replacement. If we don't have more than that, it's about replacing at most K characters. Right? It's about replacing at most K characters. You can replace less. You can replace less. Okay, so our loop adjustment is wrong. Let's rethink it. I'm gonna erase everything. It's not greater than K. Before it was, that greater than K usually comes from something like, I figured out with this example. But with the greater than K thing, that usually came with a previous problem, which was what? Yeah, we were forced to adjust our window. We were forced to adjust the window because we had greater than K in the longest with max K distinct characters. But now we can replace it. And it's similar to distinct characters too, in that we can really only have K plus 1 distinct character. That's not, I don't know if that's helpful here. And they usually build on each other, so I'm not too worried about, you know. I took a peek at the solution. They're using a hash map to track the frequency of each character. That seems reasonable. right? But I think we need to use it differently, if that makes sense. Okay. All right. So as we add characters to our window, right, there is going to reach a condition where we're going to be forced to update our window, right? What are those conditions? In layman's terms, once we have a replaceable character, we should be trying to update our max. Once we have a replaceable, let's say we have all A's. Nothing's replaceable, we just have all A's. So our calculation could just be like, but again, that's why sliding window, the last one was cool, because they actually had a start character like available, right? They actually, if we go back to the last problem, they had that starting character, right? They had that start pointing to, the start now points to something, which I was basically doing, right? You're moving the start to point to the latest character, and you're basically throwing away the other window. So in this example, where we start it's kind of similar in that we're gonna have to move it based on the. So I think we're going to pull the right character, right? So let's think like the computer, right? If I saw A, cool. If I saw B, cool. Technically, I don't know. It's a little bit. Well, let's just walk through it. We have A. Nothing to replace, right? No need to adjust any windows at all. We add a B, case equal to 1. No need to do anything there, but cool. We have another B. Ouch. Right? And why is that an ouch? Because we can only replace one character. So once we have, so since our start is pointing to A, everything non-A is eligible for replacement. Is that a fair statement? I think it is. Everything non-A is eligible for replacement. When we see a non-A character, B, basically saying if the start character So basically we're saying we want to know at some point whether or not we should be replacing characters. So what I'm thinking right now is if our start is pointed to A and we add a B, right, let me update our scene here. If we add a B, we now have an eligibly we have a character eligible for replaceable. Okay. Cool. Now, is there any other scenario here where I wouldn't want to touch the start? If the next character is an A, even in adding this character, we'd want to update our max. We want to update the max no matter what, to be honest. We just want the window to be appropriate, I think. Right? Because even at the A, I'd say, okay, cool. Max length 1. I see nothing else, right? So I think our max length calculation is going to go at the end of all the adjustments and anything like that. We add a B, okay? I heard a sound. A little creepy. Once we add a B, our end is now pointed to B. No need for window adjustment. We can skip that. But now we have what? So what's the calculation for our max adjustment? For a max length update? Well, it's going to be the count. It's going to be number of characters, right? So how do we calculate the number of characters available? Well, we had the A. The A only occurred once, right? If we look at the last problem, well, the count also matters. In the last one, it was more about the index, because it was longest substring. It was longest substring with unique characters. Yeah, the end and the start, it was okay to basically use that as a window. But why? Let's go back to the other one. I don't want to look at the solution just yet. Why was that okay in the last one? It was okay because it was already in the index. Our start gets moved anyway. Right? But why did our start get moved earlier? I mean, if we look at the solution, okay, our start got bumped because we had to throw away the entire, okay. So if our window start is here and here, and we didn't update the start unless we had to. Okay. So in the case of, we're at the A is our start. Our scene has an A with a 1 in it, right? We might say, cool, update our max with this current. Yes. This is why you don't have your phone. Well, it's not. Your dad's the only person that can text me. It's a compromise. I told her one day, I was like, I need to go down D and even you're at my D. You're like, no, what if I need you? I was like, are you going somewhere? Are you gonna die? What's going on? She's like, what if I need you? So I respect it. I guess I'm scarred like that, where if someone needed me, they just like barges in with no boundaries. So I don't really care about, Sorry, my nose is just kind of rough, I guess, huh? Anyway, so what helps us track our start here? Well, here the start's at 0. The end is at 0 plus 1. You have 1 character. So our end is going to be an index. Our start will also be an index. Let's keep track of that. Okay. We now add a B. B is not, and we're not really worried about, how do I say this? It's an index mapping because you want to keep track of like indices and like move the pointer. The start we could also track indices of. Let's try that. Let's try the indice tracker. Right. Last time we saw an A was at 0. Cool. We see a B, it's at 1. Cool. No need to adjust our window, but we do need to update our max, right? We have another character that's valid to track this. 2, it's AB. How do we track this? Well, it's going to be the same thing. It's going to be max length compared to our start, our end, which is 1, minus our start, which is 0, plus 1, that's 2. Great. So our start needs to be updated only once we have what? So if I add this B again, if I update B, what was the scenario there? B was already in the scene. So our start now points to what? So this is the last solution. This is tricky. In the current window, we will not have any right car after its previous index. And if window start is already ahead of the last one, we'll keep window start. Oh, yeah. That throws away the whole other one. Now, do I have to delete the? Not really. We'd add a C at index 3. Our start is 2, end is 3. 3 minus 2 is 1. Plus 1 is 2. Doesn't update. It's 2. We had a B. B is already in it. Okay. So what's the condition for updating our start? If B is in the thing and I don't know. What was the reason for updating B last time? Right, because it was B before. We're always doing the update. Our window defines what's replaceable. So the update's always happening. We're always saying, okay, 1 minus 1 plus 2. Start minus n minus start plus 1. Right? So we're always saying, why am I standing up at a standing desk? So we're always saying start minus n minus start plus 1. N being, if we go back to the first B of the second example, right? Our start points to A still. We just added our B to the, and we're gonna update our max anyway. So we have this second B that comes into play. And in this case, we can see visibly, right, that we have, I shouldn't stand like that. We can see visibly that we have more than K replaceable characters. I can't replace more than one character. So how do we, how do we know we have more than K replaceable characters? If we're using an index tracker, not a frequency count, but an index tracker. So let's say we don't do that. Let's say we actually keep, so we can go back to the count because it doesn't work this way, right? We don't know how many Bs we have. We know that, we have a B already. Okay, maybe that's, okay. Well, let's try to get through it. So we already have a B. Great. That's not inherently wrong. We have a B and so really this is we have a B and our window length. I'm trying to find a definitive way to define that we should be adjusting our window. That's my whole thing right now. Having a B is not the crime, right? Because if our K is 2, this is totally fine. So there's something about K that's going to come into play here. So if this character is already in the array, it's fine to move the index. That's totally fine. But we have to have, at most, K replaceable characters in our window. Right? If K was 2, I don't care. But since K is 1, we'd say, okay, if, a new character in scene and what? And what? and, end index minus our start greater than k. Is that legal? Right? Because then what would that mean? That means that we take our start. We've already got the AB. We already had our max calculation here. It's fine because it's post calculation that we're getting this other B. So it's our max length equal to max of max length. And then we'd have the end, right, minus our, I'd say, seen at start plus 1. Okay? It's okay to update our start here, right? We say, okay, start. So they were saying there's a maximum update, that you can't just point it to the next one. You can't increment it. You have to properly move it to the right spot, right? We want to move it to we want to move our start to the next B. Okay, so it was saying you either move it to the window start. So this is funny. They said that there's a case where apparently said in the current window we will not have any right character after its previous index. And if window start is already ahead of the last index of right character, we'll keep our current window start. I'm not exactly sure what that means. Let's read it again. Window start gets the max between our current window start and the +1 index of our new character. I'm a little bit confused by that. It says in the current window, right? Let's say, for example, we have the A, B, B. B is already in our mapping, correct? B is already in our mapping. So we're saying the start is at 0, B is already in the mapping. We'd say the index +1. Huh. So we have the right character, checked in the map. So we had a B that's not in there. It's 2. Another B. B's already in there. Increment it. Oh, so increment the index. That's what I got it last time. So increment the index of where we last saw this character. So now the B is now going to be index 2. That's our new B. And our start now points to either the start 0 or index 2, which index 2 is greater, so we'll point to that. In what scenario would we not want to update to the next index? Well, it's saying that in the current window, we will not have any right character after its previous index. What? And if window start is already ahead of the last index of right character, we'll keep our current window start. We will not have any right character after its previous index. We will not have a B after, oh, huh? Maybe more examples will help me. Right? Longest substring with distinct characters. A is already in there. We move it. B, C. C's already in there. We move it. Okay. I'm not sure what this is doing. Now, would this work if I just did this? I'm gonna do this. I'm gonna run this and see what happens. Three, 2, 3. So it worked. I'm not exactly sure what they were doing here. I want to find out exactly what the point of this was, but I'm not exactly sure. Yeah, I'm not exactly sure what the point of that is. Huh. Okay, well, that's interesting. Anyway, back to our problem. Updating our start. So I said, okay, if it's already in there and our window has more than k replaceable characters, the start needs to become the end. Is that correct? So the start's going to become, the index of our end. We already updated it, right? Points to that. Cool. That's it. Let's check it out. A, B, B, cool. So our start now points to the index 2. Now it's end 2 minus 2 plus 1. 1. That's fine. Our end is now pointing at C. A is still in there, by the way. Didn't move it. This is still 2. This is a index counter, right? So 3. Okay. C was not in it. We don't move the start, right? So our starts are pointing to 2. Therefore, we do a 3 minus 2 is 1 plus 1 is 2. Cool. Max is still 2. We have another B. B is already in there. We move the B to this one. And our loop doesn't update. We're done. Huh. That is so strange. Oh, another example. More examples rough your code up. For some reason in this, for some reason when I'm doing problems like this, I tend to not want to test it. I want it to work so bad that I don't want to find out in places that it's wrong. And that's terrible, by the way. Okay. So our start points to A. Our scene is here. A is not in there. Updated. I don't like this now. What? 1? 1. We add we have another A. A is already in it. Okay, A is already in it. If A is in it and end, which is 1, minus start, which is 0. So 1 plus 1, and end minus start greater than K. Right? So this is now pointing to 1. So if the end is 1, minus start 0 is 1, plus 1, that's 2 characters. Is that greater than K? Yes. And is already in it. Then we bump our new A. And we had a thing of 2 with 1 replacement. Okay? Now that's already wrong. We're live. We can have 2 A's. Well, the last problem, if we already saw it before, so having seen it isn't really a part of it. Is it really not? I mean, it is, and sometimes it's not. God, I spent so much time on this. 140. My screen has not moved. I'm literally talking for no reason. Well, I'm on video. Okay, that's fine. Mail calls. Hold on. nothing valuable there. Also kind of hungry. So in this scenario, it didn't really matter that we had seen the A before. No, because we still wanted to keep this. We didn't want to update this. So what were the conditions? The only conditions is if, damn it. I mean, let's take a snapshot and try and figure out what's going on. So we don't want to move it. So this still points here. We don't really want to move it. It'll be, this is all perfectly legal. Our B now points to index 2. Our A, we didn't move it. 0. 2 minus 0, that's 3. That's what we wanna see. That's not, you know what I'm saying? We get to C, and this is where we'd want that window to change. We can't replace more than that. We'd want it to move. So in what case? So what's the scenario here? What's the snapshot? If we look at everything on the board, our K is 1, our start's at 0, the length of our frequency is 3. That doesn't say much, right? But when you compare it to K, you might say, okay, you know what I mean? Yeah, I mean, when you compare it to K, it's okay. I don't know. Oh, yeah, we can only ever have, K plus 1 characters. So in reality, we wouldn't say greater than K, we'd say greater than K plus 1. Right? Because K plus 1 is 2. So what that means is that, back to that same principle, we can only have in the frequency, in the scene, I keep saying frequency, I keep saying scene. It's an index mapping. In our index mapping, we can only have K plus 1 total. So how do we know we have K plus 1? Length. Not n minus star, but length. So I'm saying length here. What? Scene? Length of scene. Because now it's, right, from our previous execution, we got 3. Remove our start. So in this case, so it's not really about it being seen before? I don't think so. Right? Because technically it's really just about the number of characters. So if length of scene greater than K plus 1, we bump our start to this C. I'll make a better line there. Our first C. We've caught our previous one, right? Because the length is now we're not adjusting the length. Okay, we're not adjusting the length, which is why in the, okay. So yes, that's still wrong. That is still wrong. Yeah, that's still a problem. Still a problem. Fuck, this is hard. It's hard, and it's a hard problem, right? It's meant to be a hard problem. So if it seems kind of confusing at first, yeah, it's okay. I'm gonna have the solution. I can't. I don't know. I can keep going back and forth, but I don't know. The max update's not moving, but there has to be a condition for updating the window. So if I look through the conditions, I know it when I walk through it in my mind. I know how I want to update it. So we start at A, and we add this first C. We already know because of the fact that k is 1, that this window is no longer valid. Why is it no longer valid? Because our starting character is A. We already have one non-A character in our scene mapping. Okay. We already have one non-A character. We can't have another non-A character. The funny thing is, A could be one of the replaced characters. Like I just thought of a random example. Let's say you have like A, B, C, C, or well, how would you even get to that kind of window without some craziness? I don't know. Anyway, I'm looking at the solution. I don't know what it is. I can't tell what it is. I'm kind of mad about that. I'm mad that I can't tell. But no, you're right. You'd want to move your start. So let's say we had a count. Right, let's say we had, A is 2, B is 1, C 1. Right? Technically, before even adding C, we'd want to sum up with do a max calculation, and then we'd add C. We'd move our start to the C, and then add C to the dictionary. We have to also update it. So this is becoming, in the format. The window tracking is harder now. But let's look at the solution. Let's take a look. I'll read it first. We'll use a hash to count the frequency of each character. They're counting frequencies. Let me use that hint. They're not using indices. They're using frequency tracking. Okay, it's frequency tracking. What I believe we're running into is this thing where we need to know a couple things, right? We need to know if we've exhausted our repeatable characters, right? So if we've exhausted our repeatable characters, I'm cold. If we've exhausted our repeatable characters, we will iterate through the string to add one letter at a time to the window. Cool. We will also keep track of the count of the maximum repeating letter in any window. Let's call it max repeat letter count. So at any time we know that we do have a window with one letter repeating, max repeat letter count times. This means we should try to replace the remaining letters. Yes. If the remaining letters are less than or equal to k, we can replace them all. If we have more than k remaining letters, we should shrink the window, as we cannot replace more than k letters. That all makes sense, right? While shrinking the window, we don't need to update max repeat letter count. Since we are only interested in the longest valid substring, our sliding windows do not have to shrink, even if a window may cover an invalid string. Either we expand the window by appending a character to the right, or we shift the entire window to the right by 1. We only expand the window when the frequency of the newly added character exceeds the historical maximum frequency. We only expand the window when the frequency, the count of the newly added character, exceeds the historical maximum frequency. from a previous window that included a valid substring. In other words, we do not need to know the exact maximum count of the current window. The only thing we need to know is whether the maximum count exceeds the historical maximum count, our previous max count. That can only happen because of the newly added character. What's the fucking solution, bro? So they're doing a frequent account. That this code is bread and butter, standard. Makes sense. Window adjustment, or not adjustment. So it's not always a window adjust. It's an adjustment, but it's not always the same kind of adjustment. So it basically says current window size from window start to window end. Overall, let's read the code. So there is a calculation of how much do we have nk. So what I didn't get to was a variable that would keep track, right, of how many repeating characters we have. Because a repeating character doesn't make us replace anything. So replaceable characters is equal. So simple math equation. What? I'm writing it out. So replaceable characters is equal to repeat minus length. So if we track, right, if we track how many repeated characters we have, and we can just do a calculate, that's greater than k, then we know that we have, and then we want our left character, as our start, we would subtract 1 because we're gonna increment the start. Oh, the only reason why it's because of 1 replacement. Huh. Then it wouldn't be repeating, right? We do the max. Wow. Now I could copy this exact solution, right? That's a hard one. It's a hard one because this max repeat. So I was there, right? I knew there had to be some condition. I literally almost had that. I was close. I was close. I will put it up there and I will provide a detailed solution of why this solution works. So I'm gonna say we use, I'll say what? Using a frequency dict. Pointer to the max length. And a pointer, I'll say pointer, but I'll say we iterate over the string, adding to the, I'll say frequency dict. So we use the max repeat letter count. I love how that works. How because we're moving through the array one at a time, that frequency, the max repeat letter count can be updated just by the right character. So basically it's saying if we're at, let's say for example, K10, we have a ridiculous string. If we add A 3 times and then we proceed to add a B 4 times, our max repeat letter count is 4. Right? That's kind of the cool part. So I'm saying we update max repeat letter count with so when it says historically, it means its previous value with either its prev value or with the new character count. I'll say with new characters count. I'll put an example with a string like AA and then like BBB. Max repeat letter count will be equal to the max between previously max repeat letter count, which I believe was what? A at 3, or now, or A at 2, or now it'll be what? It'll be frequency at B, which is basically 2, right? Which now equals 3. And we do that check every single time. Then we adjust our window if n minus start plus 1 minus max repeat letter count greater than k. This means that we want to shift the window over by 1 if we have more than k replaceable right? And in that case, we'd say the left character is the window start. We'd subtract 1. We'd shift the entire thing over once. So why is shifting it over once okay? Everything needs each other. This code is very clean. Everything needs each other. It's kind of weird. That's pretty standard, right? So the reason why this works so well is because we're keeping track of a count, and then we're saying the max. So when they say max repeat letter count, they mean the letter with the highest repeating value. Let me even add that in the list. Well, I say repeat. What I mean is, I say letter with the most occurrences. That's what occurrence. What? Oh, word. This is occur. No way, it's 2 R's. So letter with the most, my laundry's done. So letter with the most occurrences. I don't want to say, we need this tracker because we can only replace k characters, and if we subtract the count of then we know the rest of the is replaceable. We adjust our window if end minus start minus +1. This formula tells us that we have more than one replaceable window. So the shifting this is kind of like recursion, where there's a base case for how you adjust, but you have to keep track of like the things you use to adjust your window. So I had that. I was saying, well, there's a scenario where you'd say, well, if we have, what was I saying? So I was like, okay, if we have, A, B, C, we can't replace more than one, so we only shift it by one. So they said, even if this is an invalid window, something like that, it's fine. So either we expand the window by appending a character to the right, or we shift the entire window right by one. We still expand it, but then we additionally shrink it. We shift it up, do it by one. That's all I have to do. In previous solutions, you'd have to continually throw the window down for one reason or another. So there's a couple things that I need to keep, track of here when solving these problems. There is a scenario where you might need to continually move your window down. There's also scenarios where you have to just adjust your window by one. Or you also need to entirely move your window to point to an entirely new start. Kind of crazy. That was a hard one. That one took a lot out of me. I'm gonna run the same thing I do all the time. Let's get the code in there. I'm gonna basically copy this because I wasn't smart enough to figure it out, so we're gonna just do that. I'm gonna copy the whole thing. Fuck it. Right. I'm updating the spacing. Okay. Yeah, so current window size is from start to end. Overall, we have a letter which is repeating some. It says, but the variable is max repeat letter count. I really want to make this. I'm gonna make it something else. I'm gonna say. Now, highest is the max. What I really say is most repeating letter count. I say no. I don't know why I got up there, but anyway, I like the term highest. Yeah, I like this term more. Highest repeating letter count. The letter that repeats the most, we're gonna keep sort of in its own bubble. I'm gonna try to replace the rest. So the max update routine, that's all good and fine. And then we say if window end, right? Highest repeat letter count. Yeah. I mean, the solution makes sense because I was already there. I was like, the condition is that we have two A's, a B, and a C. But I was using the scene. It's not always about what's already in, but more about what it really was about was not what was in the counter. Like in previous problems, it was, do we already have this? But having it didn't really matter. It was more like we have this character that repeats this many times. Anything else we add to it is replaceable. Or at least the smartest way to do this would be to replace everything else. You wouldn't want to try to replace. It wouldn't make sense to have an A, B, and a C with K2 and then try to replace the A. So you'd want to keep track of that character that's repeating a lot and then only adjust if you exceed replaceable characters, which is basically your start and end minus the ones we're repeating. Start and end window minus ones repeating. Yeah, that's just yeah. But as you practice, right? Cool. Let's go ahead and add a test. And I'm going to write tests. All right, come again before I leave. Why would I? What did I just say? Oh, I might do laundry before I leave. What am I doing? Oh. String count tests. Test define function. We'll take in the S and which is a string. Type hints are great, which is an int. We're going to assert that. Assert what? Assert our highest. Whoa, that was wrong. Okay. I like this. PyTest run. I like this as well. I had no test in here. Let's do this. Now, I mean, it makes complete sense, and being able to explain it simply, I think is, I have to add K in here. I think being able to explain it in a more simple way, I'd like to be able to do. Well, K is 2, output 5, right? In this point, K is 1, output 4, and wow. Okay, run that again. So I copied the solution, but it makes sense. Yeah, I was almost there. I keep saying that because I was very, very close to that. The truth is that I had to kind of stop you though. The truth is that basically I was trying to figure out the conditions for adjusting and what the adjustment needs to be. But I've now learned something new, that you don't have to always, the shrinking doesn't have to be like this repetitive move, move, move type of thing. People are running down the hall in my apartment, and I'm very put off by this. People don't usually run in this apartment. Once in a blue moon I hear it, but it's like, what the fuck is this? I had to close this thing out, but the conditions were simple. I was stuck on this thing where it was like, okay, I have an a B, and a C. So I know I need to move my window. How? And I think with this problem, I got exposed to the idea that you don't have to. With the last one, the adjustment made sense, right? That move made sense. This one, not so obvious. It's not obvious that sliding it 1 over was okay, right? I don't know why I thought I had to get rid of the whole thing. You don't really have to do that. But I should learn to get away from, I mean, the pattern is great, but the idea of a slide, window adjustment, it can happen different ways. So I'll leave it at that. I did 2 problems here. I'm gonna leave with the last one. That's like what's it called? It's like a placeholder. That's a new problem? No, same problem. Yeah. Okay, our next problem is something gonna be something crazy, I'm pretty sure. Next one's kind of nuts. Let's check it out. So longest subarray with 1s after a replacement, which sounds very similar to the last one. We don't have to, but you'll figure out. So now we have 3 ways to mainly adjust, right? Continually move your start if needed. Completely dump the old start. Update your start to a completely new pointer, or just slide your window over once. Bad calculations don't matter because they're not going to be greater than your previous one. Something like that. Okay. But also using something else to keep track of other data, or like a helper function might also come into play. So I don't think have I been here before? I've tried to solve this one already. If I run the tests, none of them pass. As you can see, I tried to implement the last one. Frequency count, that kind of thing. Yeah, we'll see if I can do that. Not today, though. Signing off. I journaled already. I'm going to go to Jasmine's and eat some good food and go keep her company before she goes to Boston without me for a couple days. I have some social events I might need to go to. I'm trying to avoid those. I'm not really in the mood. I'm in love with this, not streaming, but recording thing. Watching it back was also kind of cool, so might watch this one back later. But that's it. I'm done for now. That was 2 problems, 1 hard, 1 medium. Or no, what did I do today? What did I accomplish? What did I accomplish? This is also one of the worst commit histories ever, right? I did this long one, and I also did the other one, right? So I did 2 hard problems in 2 hours. Let's try to make that 2 in 1 hour. Risky. Anyway, hair looking not too bad. Bushy. I need a haircut.